Welcome to video 1.3 part 2, and so I guess we are ready to take off. Where we left off was example number 11, so here we go. Number 11, 12, and 13 ask us to find the real solution, if any, and we are asked to use the quadratic formula. And we should all be familiar with the quadratic formula. Which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then it's just a matter of solving this problem. Negative 1 plus or minus the square root of 1 minus 4 all over 2, which equals negative 1 plus or minus the square root of negative 3 over 2. Now we have a slight problem. Since we have a negative under the square root, that means there are no real solutions because nothing times itself equals negative 3. And so right now we can stop and say there are no real solutions. We can go on. Number 12 is 5x squared plus x minus 2 equals 0. So x would equal negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, or 2 times 5. So this equals negative 1 plus or minus the square root of 1 plus 40 all over 10, which is equal to negative 1 plus or minus the square root of 41 all over 10. And that is square root of 41 will not simplify any further, and so there is our answer. The final problem in this group is example number 13. 5x squared plus 8x equals negative 2. First thing we have to do is get everything to one side and set it equal to 0. This is always true for the quadratic formula. So we get 5x squared plus 8x plus 2 equals 0. So then x would equal negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. This is negative 8 plus or minus the square root of 64 minus 40 all over 10. Negative 8 plus or minus the square root of 24 all over 10, which equals negative 8. And since square root of 24 can be rewritten as 2 root 6, we can do that. Now we look, the 8, the 2, and the 10 all can simplify by a factor of 2. So we're going to do so. Negative 4 plus or minus square root of 6 all over 5. And there is our final answer for number 13. Example number 14 asks us to use the discriminant to determine whether or not there's two unequal solutions, a repeated real solution, or no real solution, and here we need to talk a little bit. The discriminant is the part that's under the square root in the quadratic formula. That's the first thing. Now, if it is positive, that means there will be two unequal real solutions. If the discriminant, the stuff under the square root, is positive, there's two unequal real solutions. If the discriminant is equal to 0, then that means there is a repeated real solution. And finally, if it is negative, that means there are none. So, what we have, for example, number 14. We have x squared plus 3x plus 5 equals 0. Now the discriminant is just the stuff underneath the square root, which is b squared minus 4 times a times c, which equals 9 minus 20, which is negative 11. So, does it have two unequal real solutions? This would have to be positive. Does it have a repeated real solution? This would have to be 0. Since it's negative, that means there are no real solutions. Okay, the last group are the word problems once again, and basically we may need to have pictures, we may just need to read what it says. The area of a circle is found by the equation a equals pi r squared. If the area A of a certain circle is 144 pi, so I can put that in for the area. Find its radius, and this is 144 pi square centimeters. Find its radius. So pi r squared. Well, I need to solve for r. Well, I can divide both sides by pi, so that becomes r squared equals 144, and take the square root of both sides. R equals plus or minus 12. But it's important to realize it doesn't make sense to have negative 12 for a radius. So all we're really interested in is the positive 12. Now, since this is a word problem, we do need to label it, and it would be 12 centimeters, because that is the label that is given. Example number 16. A ball is thrown vertically upward from the top of a building 112 feet tall with an initial velocity of 96 feet per second. The distance s in feet of the ball from the ground after t seconds is given as s equals 112 plus 96t minus 16t squared. S represents the distance above the ground, t represents the time in seconds. After how many seconds does the ball strike the ground? Well, striking the ground would mean that the height would be 0. So I can put in 0 right there, and then it just becomes a matter of solving this particular problem. Now the first thing I notice, 16 will go into each and every one of these. So 0 would equal 7 plus 6t minus t squared. And I don't like negative t squared, so I'm going to multiply everything through by negative 1. T squared minus 6t minus 7 equals 0. Now, any one of the ways that we've learned how to to solve will work. And I'm going to factor here. So this becomes t minus 7 times t plus 1 equals 0. Setting each one of these equal to 0, t minus 7 equals 0, and t plus 1 equals 0. So that means t might be a negative 1 second, or t might equal 7 seconds. Now obviously negative 1 seconds does not make sense. That would mean 1 second ago. And so the final answer would be 7 seconds. And the final problem is number 17. A circular pool measures 8 feet across, and that is shown in the diagram that's given. 1 cubic yard of concrete is to be used to create a circular border of uniform width around the pool, and that is shown as X on the diagram. If the border is to have a depth of 1 inch, how wide will the border be? We're supposed to use 3.14 to approximate pi, and we're supposed to express our answer rounded to 2 decimal places. Well, the first thing we have to realize is that if we're talking a depth of 1 inch, but we have a cubic yard, the first thing we have to do is convert cubic yard into cubic inches. And that's not too difficult to do. We just have to realize that for every yard there are 36 inches. And so we can take 36 inches and cube it. And when we do that, we get 46,656 cubic inches is how much material we get to work with. Now that sounds like a whole lot, but it really isn't. I mean, it's quite a bit, but not a huge amount. So then what we need to realize is that if it's a depth of 1 inch, then that means the area of this sidewalk or this border needs to be 46,656 square inches. Now, in order to do this appropriately, what we need to first of all is determine what would that area be. Well, I'm going to take the small circle. The small circle has an area of pi r squared. Well, in this case, r is 4. And so that would be 16 pi. That's the area of the small one. The area of the big one, including the pool, would be pi times 4 plus x, the quantity squared. Now this one's not quite so simple to do the calculation. First of all, we would have to FOIL this out, so we get pi times 16 plus 8x plus x squared, and then distribute the pi. So we get pi x squared plus 8 pi x plus 16 pi. Now, to find what would the area be of just the ring, we have to take the big one minus the small one. So if you notice, that would be pi x squared plus 8 pi x plus 16 pi minus the 16 pi for the small one, which equals pi, and I'm going to factor the pi back out, x squared plus 8x. And so that is what the area of the little ring going around is. Well, now that has to equal the 46,656 square inches. So I'm going to take the 46,656, and that has to equal pi times x squared plus 8x. I'm going to divide through by pi. Now here's where, when we put it into our calculator, we're going to hold it there. We're not going to erase it and do a rounding. We're not going to round until the very last statement. So I'm going to take 46,656 and divide by the 3.14 that we've been allowed to have as pi. And so we get x squared plus 8x equals 14,858.60. Now that's just rounded, but I'm going to keep that in my little calculator. Now I'm going to look at this and say, oh, I need to complete the square here. So x squared plus 8x, half of 8 is 4, and square that is 16. So I need to add 16 to this. Since that's already in my calculator, all I have to do is press plus 16, and I get 14,874.60. Now this allows me to rewrite this as x plus 4, the quantity squared, equals 14,874.60, but I still have that value in my calculator. Then I can take the square root of both sides. Now here I only need to worry about the positive because I'm not going to worry about a negative distance. So now I'm going to take the square root of that answer. And I get 121.96. Now I subtract 4, once again, just say minus 4, and I end up with 117.96 inches, which is a nice little border going around that particular pool.